Hello everyone, so this is my entry for the challenge of Wolfie 6020, showing how the sun angles during the equinox wouldn't work anywhere on Earth, especially, or in this case we're discussing Sydney, Australia, on latitude line 33.8 south. So this is nothing but the axis, the polar axis of the equatorial mount, which is at the same angle of the latitude line 33. And during the equinox, 23rd of September, when the angle of declination is 0, that means the sun is perpendicular on the equator. We'll put this here. And we get an angle of elevation during the zenith of 56 degrees in Sydney, Australia. And on sunrise, the sun is due east, and sunset, the sun is due west. That's what we expect using an equatorial mount. And the sun elevation is 56 degrees. That's all fine. So this is how it should work on a flat earth, or that's how it works in reality. But the problem is, if this green spot is the sun, this means the sun moves this way on an arc, especially for Australia or for whatever place you'd like to choose. This cannot work on the flat earth. I'm not saying the sun of the flat earth is doing in a circle or any way. I'm just saying that in Australia, Sydney, this what we should see. But there's no way to explain this on flat earth except if the sun goes from beneath the disk of the flat earth and then goes up and give us the zenith over 56 degrees and then sunset. Now I'll move to something neat. It's the 22nd of December, and the angle of declination is minus 23.5. So if we put this here, that's the sun elevation angle during the zenith and the summer for Australia, and it's almost 90 degrees, which is the reality. Now let's see how does it look like. The globe. There is my globe right there. So this is the equinox. No, sorry. This is the equinox, where, as you see in the middle of the screen, almost in the middle of the screen, the equator. So the sun is perpendicular on the equator, and this is the polar axis, or the rotation axis of an equatorial mount. And if we take the 23rd of September, we put it right there. Now we are the sun. See, it's pointing toward us. This is the sun ray. So we'll look at it from another angle. So now this is the sun from the east, and then the earth is rotating. Now let's look at the other side. What do we see? Now it has turned for 12 hours, and that is west in Australia. And the best way to see it, put Sydney in the middle of the bowl and look, so that is west. Now let's try it with the summer in Australia. Negative 23 degrees, that's the 22nd of December. When it's the hottest time there in Australia. See, if we are the sun, then this thing is pointing at us. It's not perfect, but it gives you the idea. Now let's see how does it look during sunrise. That's how it would look during sunrise, southeast, and then on sunset it is southwest. And if we get our flat earth map back again, if the sun is rotating somewhere above the disk here, so how can it rise from southeast and set in the southwest? So the equatorial mount is such an elegant device that I thought it's not fair to just put one case of the equinox, and that's why I put the 22nd of December to show the use of declination angle and how it displays the direction of the sunrise and sunset and the elevation angle during the zenith. So if any flat earther is able to understand the equatorial mount, I'm not saying that he's going to change his mind, because this is almost impossible, but he should stop for a while and try to reassess the situations or the information he received before and do more research. So I hope this at least urge flat earthers to do more research about the sun. The sun is not a reflection, the sun is not a hologram, the sun is not some source of light that we see in different position due to refraction, because none of those hypotheses is backed up by any scientific evidence or even can be calculated as much as we can do with the math, which is based, for me at least, is based on the equatorial mount. This was the start for me to make my own sun calc application. So thank you all for watching, and wish me luck. Bye bye.